All right, welcome to part 2 of the quarter 3 review. This is going to go quickly because there's a lot of problems here to do, and I am fairly certain that if we made the video very detailed and 3 hours long, no one would watch it. Assume that y varies inversely with x. Okay, so there's direct variation, which is y equals kx, and then there's inverse variation, where y equals k over x. And it says right here that this is inverse variation. So we know that y equals k divided by x. Then it says if y equals 23 when x is 2, so 23 equals k over negative 2, what is the constant of variation? Well, that's k. So all I have to do here is multiply both sides by negative 2, and I'll get negative 46 equals k. Same thing here. Assume y varies directly. So y equals kx. So 18 equals k times 6. Divide both sides by 6, and I get k equals 3. Let's go right on into the next problem. Point A is an element of a direct variation. Plot, draw 2 points other than A that are also elements of the direct variation. Now, one of the key features of direct variation is that it always goes through the origin. So there's my first point. Now, direct variation is a line, and so the slope is constant. So between the origin and A, we rise 2 and we run 3. So our next point, we could rise 2 and run 3 and get that point. Over here, it's the same thing. Here, we know we go through the origin, and here we rise 3 and 1, rise 3 and run 1. And so we can rise 1, 2, 3 and run 1. And there's our other point. The key here is that it's a straight line through the origin. Sania's paycheck earnings vary directly as the number of hours she works. So P equals KH. If she works 21 hours and earns $189, well, first we need to figure out what K is. So I divide both sides by 21. And I get K equals 9. So our full equation is P equals 9H. And so to find out how much you get paid if she works 32 hours, I just plug in 32. And she would get paid $288. How do you determine if a graph is direct variation? Easy. It goes through the origin. All right, scatter plots and line of best fit. So write the line of best fit for the data. So in order to do the line of best fit, I'm going to have to put the data into the calculator. There it is. So in order to put the data into the calculator, you're going to hit the Stat button, and you're going to choose Edit. And then we put the data in. 0, 1, 2, 3, 4, 5, 6, 7. So we put the X values into L1, and we put the corresponding Y values into L2. Oh, it looks like I mistyped there. This was 322. Make sure to put the values in correctly. Oh, I messed this all up. Let's start that again. So the first value was 282. The next value was 295. The next one was 322. It's very important that for when you do this, that 5 and 471 are across from each other. So Oops, sorry. $508, and lastly 550. So once we have the data in the calculator, then we can calculate, stat calc, the line of regression. X's are in L1, Y's are in L2, we're good to go. And so we calculate. Uh-oh, go to. When did I mess up? All right, so 0, 282, 295, 322. Huh, I'm left out 396. That's not going to help things. 427. So once again, across from 5 has to be 471. That's odd. It's like it didn't go in. 508. Nope. 508 and 550. Enter. There we go. There we go. And so we get the equation. Sheet here a little. Oh, all right. Well, I guess that's the way it's going to be. Y equals 40.702x plus 263.917. In the absence of instructions, go to 3 decimal places, round to the 3rd decimal place. That's the AP standard. Estimate the number of alternatively fueled vehicles in the year 2015. Well, the key was you have to read the problem here, and this is years after 1997. So really, this is 1997. This is 98. This is 99. This is 2000. So in order to do 2015, I would need to put X is going to have to equal 18, because that's 18 years after 1997 is 2015. So we will take our calculator and we'll say Y equals 40.702 times 18 plus 263.917. And here I'll do it on the calculator on the board. So 40.702 times 18 plus 263.167. And we get around approximately 995,000, because the values are in thousands. So how many vehicles will there be? 995,803. Because these are not the number of vehicles. Number of vehicles are given in thousands. Whoops, in thousands. All right, so another problem. So you really should get in the habit of rescaling your axes when they give you years. You don't want to put in 1900, you just want to put in 60, 70, 80, 90 instead of the year. It's a good habit to get into because the years are the numbers are so large that it's going to mess up your equation. So once again, we will put the data into the calculator. Let's bring it over here so I can see. Stat, edit. Now, if you want to clear out your data, clear it out. Don't delete it. So arrow up, clear, enter, and it'll clear everything out. So I can go 60, 70, maybe 80, 90, 5,063, 6244, 784. 40 and 9179. Stat. So define my variables. X is years since 1900. Y is population. And so we do stat, calc, line of regression, calculate, and we get y equals 139.44x plus, actually, minus 3376.5. If you don't rescale the axis, you have to go to a lot of decimal places here, and the y-intercept becomes enormous. So what we guess the population will be in 2017. Well, so we won't plug in 2017, we'll plug in 117 because that's the number of years since 1990. So we get y equals 139.44 minus 3376. That's a 7, right? Double check. Yeah. 0.5. And, oh, sorry, we're plugging in 117. Oy. So 139.44 times 117 minus 3376.5 is the population will be approximately 12,937.98. Now you obviously can't have 0.98 people, so we could also just say approximately 12,938 people. This is once again just the same type of problem. Oh, whoops. Still have the pen on. So stat, edit, put the data in. 3, 7, 10, 15, 18. Corresponding y values are 16, 45, 82, 102, 16. All right. Stat, calc, line of best fit, calculate. Y equals 6.711 x plus 1.066. So find the value when y is 125. So now I'm going to plug 125 not in for x, but for y. So now I have to solve this for x. So I'd subtract 1.066 from both sides. I get 123.934 equals 6.711x. So I divide both sides by 6.711. And I get an answer that x equals approximately 18.467. All right. We're going to come back to that in a second, but for right now, which graph below represents the equation y 5x minus y equals 2? So what we want to do is we want to solve, I should write meter, we should solve this equation for y. So I subtract 5x from both sides, or if you prefer, I move it to the other side and it becomes the opposite. Now, but this doesn't say y equals, it says negative y. So we divide or multiply, because they're the same thing, both sides by negative 1. And I'll I'll get y equals 5x minus 2. So first thing I need to do is find did I make a mistake? Hold on one sec. Did make a mistake. I wrote the equation down wrong. It wasn't 5x minus y equals 2. It's 5x minus equals negative 2. So at the end, this will become plus 2. So I need a line with a y-intercept of 2 and a slope of 5. And the answer is C. All right, for this one, I know that the slope is negative 1/5. I know the y-intercept is 2. Remember, a negative slope means the line's going down. So the answer is B. All right, write an equation for a line that passes through the point negative 2, 1, and 8, 3. And I'm going to show you two different ways to do this problem. The first way is to use the formula for slope, which is the change in y over the change in x. So this is x1, y1, and this is x2, y2. Oh, sorry about the bell. So this will be 3 minus 1 over 8 minus negative 2, or 2/10, or 1/5. So there's my slope. And I know that y equals mx plus b. So I can use my first point when y is 1, the slope is 1/5, and x is negative 2 plus b. I can just solve this for b. b equals negative 2/5 plus b. So I will add 2/5 to both sides, and I'll get 7/5 equals b, or b equals 1 and 2/5. Now let's just double check our work here, and I want to show you how I'm going to double check my work. First, I'm going to use the calculator, because we all make mistakes. Now, the last thing we were doing a few seconds ago was using the calculator to find the line of best fit. And one of the things that you'll learn in geometry is that if you only have 2 points, they form exactly one and only one line. Well, they gave us 2 points, so we can have the calculator find the line of best fit between these 2 points. And what's cool, so xy, x, y, is what it'll do is it will calculate the line of best fit, and it'll give us exactly the same thing. Now you can say, but Mr. Tyler, it didn't give us the same thing. It said, so it says the slope is 0.2, according to the calculator, and b was 1.4. Well, if we go back to our calculator, whoops, every time. We go back to our calculator and we go 0.2, and we go math, enter, enter. Sure enough, that's 1/5. If I go 1.4 and I go math, enter, enter, there's my 7/5. So you can use the calculator to do this problem if they give you 2 points. Now, you can say, but they didn't give us 2 points in this one. Well, yes, they did. It goes through the origin. Now, this one's fairly easy because I already know the y-intercept is 0 because it goes through the origin. That is the thing. And so then the slope is, once again, let's do x1, y1, x2, y2. So m equals 5 minus 0 over 3 minus 0, or 5/3. So my equation is simply y equals 5/3 x. And because it goes through the origin, we know it's a direct variation. All right, 49, horizontal line. So if you have a horizontal line, it looks like that. And a horizontal line is always y equals a constant. So this will just be y equals 7. Now a vertical line is always x equals a constant. So this one will be x equals 5. Once again, I'm going quickly, but we got a lot to go over here. So for 51, there's a couple different ways you could attack this problem. The key thing for a line, the rate of change, which is also the slope, is constant. And for a quadratic, it is not. So what we need to do is we need to see a constant rate of change here through these. So as x goes up 1 here, y goes down 9. And then as x goes up 1, y goes, the change here was 9, the change here was 7, the change here was 5, the change here was 3, the change here was 1, and the change here was actually -1. So that's going to be a quadratic function. For 52, right, once again, the x's are changing 1 each time. 4, 4, 4, or actually -4, -4, -4, -4, -4, -4. So the rate of change is constant, so that's a linear function. All right, so graphing linear functions, just as a quick review. Remember, m equals 2/5, b equals -1. So b is the y-intercept, and then we're just going to go up 2 and over 5. Could also go down 2 and back 5. And there's our line. Graph the equation y equals 3. Well, if it's y equals 3, it's just a horizontal line through 3. Okay, so this one's a little trickier because it's not set for y equals. So I'm going to have to subtract 3x from both sides. I'll get 3y equals -3x plus 9. Then I'm going to have to divide both sides by 3. I'll get y equals -x plus 3. So the slope is -1, and the y-intercept is 3. And so there's our graph. All right, 56, same thing. We're going to have to solve for y. Subtract 2x from both sides. -3y equals -2x plus 12. Divide both sides by -3. And I'll get y equals 2/3 x minus 4. So the y-intercept is 4. The slope is 2/3. Sorry, that line was a little off. There we go. All right, identify the slope and the y-intercept from the equation below. So once again, I want to solve it for y. I'll get -5y equals -2x plus 15. Divide both sides by -5. And I'll get y equals 2/5 x minus 3. So the slope is 2/5, but the y-intercept is -3. All right, so this one's a little bit different because there's no y. Notice there's an x, but there's no y. So if it's this equation eventually, if I add 4 to both sides, it'll be 1/9 x equals 24, multiply both sides by 9, and I'll get x equals 216. Now, but what that means, it's a vertical line through 216. So the slope, if it's a vertical line, is undefined. And the y-intercept does not exist. It never crosses the y-axis. Okay, we're almost done here. Right out, now we're getting back to stuff we did in the first quarter. So the cube root of 7. The cube root of 7 less than twice a number, so 2x minus 7. Because it's 7 less than twice the number. 6 times the square root of a number divided by 3. Now, the quotient of a number cubed in 5. Quotient means divide. right, so our properties, -5 plus 5 equals 0 is the additive inverse property, or the inverse property of addition. This is distributive property. This is the zero product property. Anything times 0 is 0. Or if you multiply two numbers and get 0, then one of the numbers has to be 0. Here, the order doesn't change. What's being inside the parentheses or what's hanging out is changed. So that should be the associative property of multiplication, which is not one of the choices here, but that's the associative property. -3 times this one is the multiplicative inverse. And this last one is the identity property, which is anything times 1 is itself. This one was not used, the commutative property. The commutative property would have been something like that, where the order changes. All right, so 63, what value of x makes this equation true? So what they're asking you to do is to solve. So I want to get rid of this 3 on the bottom, so I'll multiply both sides by 3. And I'll get 30 minus 9x equals 2x minus 3. I like positive coefficients, so I'll add 9x to both sides, and I'll get 30 equals 11x minus 3. And then I'll add 3 to both sides, and I'll get 33 equals 11x. And I'll divide both sides by 11, and I'll get x equals 3. Once again, going real quick, because at this point we've been watching the video for quite a while. So I'll multiply both sides by 2, and I'll get 8x plus 12. Subtract x from both sides, I'll get 3 equals 7x plus 12. Subtract 12 from both sides. Make sure I did my math right here. And I'll get -9 equals 7x. Divide both sides by 7. And I'll get, oops, sorry, that's not what we wanted to cancel. Divide both sides by 7, and I'll get x equals -9/7. Let me just double check that real quick. Now, you may protest and say, but the answer didn't come out to an exact number. Well, that's how real life works. You go to 7-Eleven, it's not exactly $2 when you buy your drink and your snack. It's going to be $2.11 or 13 cents. That's what we should see here. All right, solve the inequality. So solving an inequality is exactly like solving an equation with one distinction. We're going to see that distinction in a second. So we'll combine like terms here. First we distribute, then we combine like terms. So this will be -3x minus 4, because 8 minus 12 is -4, is greater than 32. Then I'll add 4 to both sides, and I'll get -3x is greater than or equal to 36. Now, here is the important step. When you divide or multiply both sides of an inequality by a negative number, you have to flip the inequality. And I'll get x is less than or equal to -12. All right, so these are all just plug-in problems. All this notation says is, it says if f of x equals 6x squared minus x plus 10, what is f of -2? So all that's saying is plug in -2 for x. So this will be 6 times -2 squared minus -2 plus 10. So that'll be 6 times 4 plus 2 plus 10. And that will be 24 plus 12, or 36. Same thing here. So this is f of 4. Actually, let's change colors just so we're clear. So back here we would say f of -2 equals 36. So f of 4 equals 4 squared plus 7 times 4 plus 3, which is negative 16, because we square it, then we do the negative, plus 28 plus 3. And so f of 4 is 15. This last one is f of negative 1 equals 5 times negative 1 squared minus 3 plus 1 equals 5 minus 3 plus 1, because negative 1 squared is 1. And that will be 3. All right, what is the solution for x in the equation below? Now, some people freak out. They're like, there's a mistake. There's a c in there. Not a mistake. There's also an a. What you have to do is you have to go through the same steps you would go with math, the same math steps, I'm sorry, you would go through before when we had numbers instead of variables. So this is solving a literal equation. So I want to get x by itself, so I subtract 6 from both sides. 6 minus 6 is 0, so this side is now ax. I can't combine those, though, so I just leave that as c minus 6. A times x, well, I want to divide both sides by a. And there's my answer. X equals c minus 6 over a. All right, same type of thing. We'll solve the equation for x below. Subtract y from both sides. 180 minus y equals 2x. And I would divide both sides by 2. And I would get, there's two different ways you could write this. You could either leave it like that, x equals 180 minus y over 2, or you could split it into the two pieces and go 90 minus y over, sorry, that y didn't come out, minus y over 2 equals x. These both say the same thing. All right, so what is the range of the function f of x equals negative x squared plus 5 when the domain is? Well, remember, domains are the x's and range are the y values. So all they're doing is saying plug this, this, and this in for x and tell me what y is. So f of negative 2 is negative 2 squared plus 5, and that'll be 1. F of negative 1 equals negative 1 squared plus 5, and that will be 4. And then f of 3 equals negative 3 squared plus 5 will be negative 4. And so my range is negative 4, 1, 4, because we always put our numbers in order from least to greatest. All right, and last, circle the relation below that does not represent a function. So if you draw a vertical line, it should never intersect a function more than once. And if we look at this and this, it intersects more than once. So this and this are not functions. Now, I went pretty quick, so if you have any questions or anything I did, go ahead and ask your teacher next class.